Alright, hey everyone, today was day 15 of Advent of Code, and today's problem was all about hashing. So we got some algorithm in order to hash a string of characters into a single number, and in order to do that, we start with a current value of 0, and then we go through every single character of the string, and first we evaluate the ASCII code for this character, then we add the ASCII code to the current value, afterwards we multiply the current value by 17, and then we consider the current value modulo 256. And then we repeat for each other character in the string. And for the problem itself, we have a list of instructions, comma separated. So this would be the first instruction. And for those 4 letters, then we have to calculate the hash function or the hash value. And then for all those instruction strings, we sum the hash values up in order to get the solution. So in order to do that in code, the important function is to have this find hash function of a string. So as described in the problem, we set the current value to 0, and then we go through every character in the string. We find the ASCII value by calling this order function provided by Bytner, and then we add the ASCII value to the current value, multiply the current value by 17, and consider the whole thing modulo 256. That allows us to solve the problem. So we have only a single line as an input. We split it into parts by this comma character, and then for each part we find the hash, and then we sum them all up to get a solution. And if we run it on the test input, that should, yes, that gives us the right solution. So we'll also run it on the real input, and it also turns out it gives us the right solution. In part 2, we actually get to know what all those instructions mean. So we have a list of 256 boxes, and each instruction tells us to either remove or add a particular lens with a particular focal length to a particular box. So we got 2 kinds of instructions. One of them is with an equal sign, such as this one, and then the first letters at the beginning will tell us both the box number as well as the label for the lens. So in order to get the box number, we just take the string and calculate the hash function on it. That will give us a box number. And then we add it to the box of this box number. And we add the lens of focal length 1 and with label Rn. And in order to add it, if there is already a lens with the same level, we just take the old lens out and add the new lens to it. So in this case, the focal length might change. Otherwise, if there is no lens with that particular label in the box yet, we just add it at the end. So essentially, we have a list of lenses for each box, and we add it to the end of the list in this case. The second instruction is with a minus. So in this case, something like QP minus. And that tells us, again, the first letters tell us both the box numbers as well as the labels. So in order to get the box number, we take the string QP and hash it. And in this case, it will give us box 1 or number 1. And then if the box 1 has a lens labeled QP, we remove this lens from the box. So in this case, box 1 starts with having this QP lens, and then it's empty. It doesn't have any lenses anymore. And we keep the order of all the other lenses the same. And then in order to get our solution, we just go for each box and for each slot in each box, and then the solution will just be sum of this a value for each lens. So we just multiply the box number times the slot number times the focal length. In order to solve this problem and store the content of each box, we need a data structure that preserves both some kind of order, and we also want to be able to delete entries based on the label. So what we can use for that is an order dictionary. So an order dictionary is essentially a dictionary where each key also knows the previous key and the key afterwards. So it preserves the order of things added to it or keys added to it. And in high version of Python, every dictionary is ordered, but just for clarity, we explicitly use the order dictionary here. And then we present our box contents as a list of ordered dictionaries. And then the 2 functions we have to do calculate is to remove a lens and to add a lens from those boxes. So in order to remove a lens of a particular label, we first find the box number by calculating this hash number for the label as in part 1. And then the correct box will just be the box given by this index. And then in order to remove the lens, we just pop from the order dictionary. So that just if the order dictionary has a key that's equal to the label, then it will remove the corresponding key and the value as well. Otherwise, it will do nothing. And so importantly, our box contents, the order dictionary, will be a map from the label of the lens to the focal strength of the lens. Similarly, if we want to add a lens to this box contents with a particular label and a particular focal strength, we again find the correct box by hashing the label, and then we can use this function to do the insertion. So if the label is already a key in the dictionary, or if the lens of a particular label is already in the box, we're told to just change the length so that it has the new focal length. So that works with this function as well. And otherwise, we're supposed to add a lens with the correct label and focal length to the end of the list of lenses. So this is exactly what this does. If label is already a key, then they will just change the value, and otherwise, if label is not a key in the box content or the dictionary yet, it will just add a key at the end of this order dictionary. With that, we can solve the problem. So our box content, as mentioned before, will be a list of order dictionaries, and then the steps we get by, again, parsing or splitting a single line by the comma. And then we go through the steps. If there's a minus in the step, that means we're supposed to remove a lens. So we call this remove lens function. And otherwise, if there's an equal sign in the step, then we add a lens based on with the corresponding label and focal length. And then in order to find a solution, our solution is this product of three numbers: box number times position number times focal length. We just go through each box separately and calculate the focusing power of the box, and then multiply that times the box number, and that will be a solution. And in order to get the focusing power of all the lenses in a particular box, we just go through this order dictionary, and there the order will be important because the position tells us how to calculate this value. So we could just go enumerate to get the position and the focal length, and then the total focusing power will just be the product of those two values. Yes, with that should solve the problem. So of course we run it on the test input, and that looks good. So we also run it on the real input, and it also gives us the right solution. All right, that's it for day 15. I hope you enjoyed today's puzzle, and see you around.